No, like in your like people, like you look like the white version of me. Like you're like the executive version.
I'm actually not even.
No, not even.
That is not West. You seem that's West is not north. Are you said?
No way, you're trying to.
I'm not trying to pass as a South Indian. I'm just not a North Indian.
You're like.
Yeah, exactly. I'm in the middle of India.
No, this sounds like better.
Bro, I don't like being a South Indian. Imagine eating Indian. No, I know.
Okay,
No, you said I'm claiming
this is
something.
so we're going through our final.
I'm being eating South Indian.
Like
my two.
coconut stuff. But we are going to after we finish this, we are going to focus on kind of A/B content pre-response questions in terms of the important ones that we want to make sure that we go over. But let me just go over the calendar real quick here. We did area on Friday, and we're really just going to be building off of that concept for volume. So we're talking about volume by this method. We're doing washer method tomorrow and the cross section, but it's all just built off of the same foundation that we learned with area. And we'll spend 3 days going over different ways that we can create volume of finding a volume using integral applications. And then we'll do quiz review on Thursday. We'll have 3 days of quiz review. So we'll do Thursday review, Friday review, and Monday review, and your quiz will be Tuesday. Okay. So again, no test for this unit. It'll just be a quiz. After that, we'll have a test and a quiz after break. Okay, so there will be a FRQ test. It'll be that probably not the week that we get back, but the week after, and then we'll also do a FRQ quiz. So we'll have so the grades remaining is we have 2 quizzes and 1 test remaining for this semester. As far as help sessions go, I'll send out a schedule for review. I'm kind of going back and forth between A, B, and PC here. So the help sessions I'll have for BC will be this Thursday and Monday. So Thursday morning and Monday morning. Quiz will be on Tuesday. Right. Oh, and by the way, on Wednesday, this will be senior service day. So in class, it'll just be a study hall on Wednesday. Okay. Okay, let me just review real quick with area formulas, and we can go directly into talking about volume. So we talked about how there are 2 different orientations of area. If we see a graph above each other, if we see 2 functions that are in terms of y, and our bounds are in terms of x, we can just think in terms of, okay, top graph minus bottom graph. We're essentially adding infinitely thin vertical rectangles from one end of the boundary to the other. The other scenario is where everything's in terms of y, and our equation will look like x equals. So if you look at this, where x equals q root of 2 minus y, x equals 2 minus y cubed, these are all in the form of x equals, and the right side is in terms of y. So if our expressions are in terms of y, that means our graphs are to the right and to the left of each other. And this is a right minus left method. So we do right graph minus left graph. Everything's in terms of y. Our bounds are also in terms of y. And visually, we're thinking in terms of stacking horizontal rectangles from the lowest boundary to the highest boundary, okay? And using that to formulate the area of that region. So let's go to page 7. So I want to show how similar area is to volume, but we have to. But I think it's good if we can kind of have area as a kind of like as an anchor. So let's do this first. Let's find the area under this curve, y equals square root of x. Y equals square root of x is just this curve here between 0 and 4. Okay, so I'm going to shade in this region here. We're just simply going to find the area of this region. Now we have two graphs here. We have y equals square root of x, and we also have y equals 0. These are both functions, and one is above the other. We're going to do top minus bottom. We're going to go through top graph minus bottom graph. So our area is just the integral from 0 to 4. And I'm going to draw one representative rectangle. Obviously, the rectangles that's going to form are going to be infinitely thin rectangles. Infinitely, all the rectangles have different heights, but we're going to extend from this end to this end. But this is one representative rectangle. And if we do top minus bottom, the top of the rectangle is sitting on the root x. The bottom is sitting at the 0. And I just want to show you the area components within this formula here. So the root x minus 0 is this minus this, right? It's going to represent that height component of these infinitely thin, infinitely many, and infinitely different heights of all these rectangles. And dx represents these infinitely thin widths of each of these rectangles. So we kind of see that width times height, right? That area of a rectangle kind of built into this definite integral. So if we work this out here, power rule, x to the 1/2 becomes x to the 3/2. And then we evaluate our bounds and we get 16/3 units squared. It's unit squared because we have two dimensions here. Width is a unit, height is a unit. Unit times unit, we get unit squared. So essentially, the integral notation allows us to add infinitely thin, infinite numbers of differently sized rectangles to form the area calculation. Okay, so we're going to take this and adapt it to form a volume of an object. So this is called this method. So this method, we're going to take the region that we created, the shaded region that we started with, and we're going to rotate that shaded region around the x-axis, 360 degrees around the x-axis, and we're going to basically create this bowl-shaped object that is completely filled in. There's no gaps. So we're essentially starting with this, but arriving at a volume of this object. Okay. So this is how we can think in terms of how to arrive at the volume of this object. So again, I'm going to shade this region here. It's the same graph here, y equals square root of x. We're going to rotate this around a center, and that center is going to be our axis of revolution. So now, instead of adding infinitely thin rectangles, we're not going to add infinitely thin cylindrical discs, circular cylindrical discs. And you can kind of imagine how if we were to take this region and kind of break it up into infinitely thin shapes, they're all going to be circular discs, right? Infinitely thin circular discs. Now, starting on the axis of revolution, we're going to extend to the furthest boundary of our shaded region. Now, instead of thinking of the height that we just created as the height of a rectangle, now we need to think of this as the radius of these circular discs. So we're going to call this, so I'm going to shift over to this shape here. We're going to call this R of X, which will represent the radius of these infinitely thin circular discs. Now, what's the area of a circle? R squared. So pi r squared. Now, if I do pi r squared, how many dimensions is that? 2, right? So that's going to give me the face of this circular disc. But we're also going to have a dx, a width component of these discs, and that's going to give us that third dimension. So the volume of these circular discs is pi r squared, which is 2-dimensional, times a third dimension, that dx, which gives it that width. So our volume formula is the integral from a to b, pi big radius squared dx. So before, we only have 2 dimensions, right? Height and width. Now we have area and width. So area is already 2 dimensions. If you do two dimensions and then add on that width component, that gives it that third dimension. Okay, so we're going to solve this problem with example 1. Okay, we're going to find the volume of this particular cylindrical or this bowl-shaped object that we can think of as adding infinitely thin circular discs. Okay, so example 1, find the volume of the solid formed by rotating the curve around the x-axis between the x values of 0 and 4. So again, same shaded region. Draw on your axis. Now, the orientation of your axis is important because the way that we're going to draw our radius is always going to be the distance from the axis of revolution to the boundary of the shaded region. So this will be a good habit for us to build as later on we're going to be dealing with gaps in the graph. So wherever you draw your dotted line, go ahead and start your pen or pencil on that dotted line. It doesn't seem like a big deal right now because right now there's only one way to draw these radius. But later on, I think it's really helpful if we just always start our radius length starting from the dotted line. Right? So from the dotted line, we're going to extend to our boundary, and we're going to call that big R of X. This is one representative radius of these cylindrical discs, right? We know that there are going to be infinitely many, infinitely different, but right now this just give us a way for us to identify the functions that we need to build this radius. So now let's do big R of X. We're going to find big R of X the same thing, same way as before for rectangles. We'll do top minus bottom. So what's the top of the radius sitting on? Which curve? Root x, okay. Minus, okay, what's the bottom of the radius sitting on? 0. So root x minus 0. So basically it's the same as the height here, but now it represents something different. It represents the radius of these circular disks, right, which is root x. So now we can start putting into our formula. We can push the pi out because pi can be thought of as just some coefficients. And then we say v is equal to volume is equal to pi, depth integral from a to b, from 0 to 4. Radius squared. So there's my pi r squared. There's my circular shape built into this volume formula, dx. And eventually, we're going to plug this in the calculator because our formula will get more and more complicated. But this, we can do this by hand. It's not too bad. So root x squared just becomes x. And this is just the power rule. X squared over 2. Evaluate between 0 and 4. So we get 16 over 2 minus 0, which is 8. Now, we don't want to forget about the pi here. There's that pi r squared. So we say 8 pi and then units cubed. Now, as we move into plugging this into our calculator for more complicated problems, typically I like to have you leave the pi out of the calculator, because if you put pi in the calculator, our calculator won't be able to give exact value. It'll give some decimal value, and typically on the AP exam, they want exact values, even at this calculator section. So I'm going to be asking for that on the quiz. I want you to show me your answer with pi in it. So you're not going to put pi in the calculator. You're just going to attach pi to your numeric solution. Any questions so far? All right, next page. All right, example 2, we have y equals 2 minus x squared and another function g of x equals 1 revolved around the line y equals 1. Okay, so I forgot to mention that we have 2 equations and we have an axis of revolution. So let's graph these 2 equations here. We got 2 minus x squared. That's really just the parabola with a y-intercept of 2 that's opening down. Then you have y equals 1. So there's our shaded region. And we're rotating this about the line y equals 1. So our axis of revolution is here. We're going to rotate that shaded region around this dotted line. So it's going to kind of form like an egg-shaped object. Let's go ahead and find the intersections, because the intersections will give us the boundaries that we need for our volume equation. So So 2 minus x squared is equal to 1. Two minus 1 is 1. Move the x squared over to the left side. So I get x equals plus or minus 1. So let's move into creating our radius. So we're going to be adding infinitely thin circular disks from -1 to 1. Start on your dotted line, and from your dotted line, extend to the boundary. And that's going to be your radius representation. Okay, let's build our radius length. Top minus bottom. The top of big radius is sitting, top of radius is sitting on which graph? 2 minus x squared, okay. So it's top minus bottom, and the bottom of the radius is sitting on what? On 1, yeah. I like to always put that bottom expression in a set of parentheses. I mean, you're not going to really need it with only one term, but if there's multiple terms, we want to make sure that we distribute that negative through all the terms. So in this case, I can reduce this to just be 1 minus x squared. So this falls under the top minus bottom horizontal axis of revolution formula. So pi from -1 to 1, big radius quantity squared dx. Sorry, 1 minus x. Right. We could plug this in the, we could work this out by hand, but I do want us to practice using our calculator, since eventually all these problems are just going to be, after you set up, you're just going to make the calculator do all the work for you. So I like to do this. I like to hold radius under y1. That way, when I have to call it again and again, I don't have to keep typing it into my home screen. So under y1, I'll type in my radius, 1 minus x squared. Okay, after that, go back to your home screen. So do second mode. Okay, we'll activate the Math 9 FN integral feature there. So Math 9. Again, leave pi out of your calculator. You're going to go from -1 to 1. You already have your radius held under y1, so do alpha trace, call y1, square that, dx. Also, the nice thing of having your y1 hold your radius is that on the home screen, you don't have to worry about doing a bunch of parentheses, which can, it's just really messy to have to enter everything into your home screen. So I like to split it up. I like to have my y1 hold my radius, and later on, we're also going to have small radius for a hole that we can subtract with washer methods. So it's really nice to have kind of break them up into multiple screens. Hit enter. Sometimes your calculator is able to convert to a rational value. So always see if we can get there. So if we do math fraction, it'll try to get into fraction form. If you can't get into fraction form, then you'll just round to 3 decimal places. But this one can, so we'll say 16/15 pi, don't forget about the pi, units cubed. But if it doesn't convert, then you'll just say 1.067 or 1.066 pi units cubed. So whenever we're dealing with graphs that are top minus bottom relationship, it's always the easier one. But as soon as you see your radius being horizontal or your rectangle being horizontal, that should be a clear indication that, okay, there's more work that needs to be done. I need to spend time to rewrite the equation, because the equation that's given to me is usually not going to be in the correct form for right minus left. So if we see anything horizontal, radius, those are the more involved algebraic problems. Okay, so let's see what that looks like with example 3. Okay, so given the region formed by the function, find the volume, the solid formed by revolving the region about the y-axis. So now we're rotating about the y-axis, which is going to make everything a little different here. So, but our shaded region is still the same here. But now we're rotating about the y-axis. So this is going to fold over here, and it's going to kind of rotate around this. Is going to kind of create like a cone shape object. Again, now with these objects, you don't have to worry about what it looks like. As long as you can identify the most important pieces and put into the formula, that's really all we need to do. Right, again, you're going to put your pen or pencil on the dotted line, and you're going to extend from the dotted line to the boundary of your shaded region. In this case, you have to go to the right. If you go to the right or left, that's an indication that something is different. This is a right minus left relationship. I'm stacking horizontal disks from the bottom to the top, which means that this is not a good fit for our formula. We need to do this one. We need to get our equations in terms of y, and the left side will look like x equals. Our bounds are also in terms of y. So everything we have to kind of adjust to that new perspective. So this equation is y equals negative x plus 1, but it's not in the correct form for us to do right minus left. So I need to solve for a different variable. I need to solve for x. So if I rearrange this equation, x equals what? Yeah, negative y plus 1, or I can say y, 1 minus y. So I like to see that x equals, because when I see that x equals, that reminds me that I'm in the correct form, that the right side is ready for my right minus left. Yes. Yeah, it depends on your axis of revolution, right? So if your axis is vertical, the only way I can get from this dotted line to the bounded region of another graph is horizontal. Right? I can't move up and down if my axis is vertical. Yeah, so basically it's this. If I have a vertical axis of revolution, I'm always going to be dealing with horizontal radius. If my axis of revolution is horizontal, I'm forced into drawing vertical radius.
So both A and B both be vertical.
Yes, A and B will both be vertical because we're rotating about the y-axis. Okay, so another point I want to point out, another point that I want to make sure that we understand is that your axis and your radius will always be at 90-degree angle. Okay, so if your axis is vertical, then your radius is horizontal. If your axis is horizontal, then your radius is going to be vertical. Okay, so they're always going to be 90 degrees with each other. Okay. We also need to adjust. We have another equation to worry about, right? So the right endpoint is touching the graph. The left endpoint is sitting on the y-axis. What's the equation for the y-axis? X equals 0. And having these forms is helpful. It just reminds us this is in the right form that we need. X equals, X equals. We know the right side is ready for us to plug in for our this method for these right minus left formulas. Now, our bounds are also y values. We have to think in terms of that we're stacking these horizontal disks from the lowest to the highest y value. What's the lowest y value that you see?
0.
What's the highest y value? 1. So your bound is from 0 to 1. Let me build radius first. R of y. Right minus left. The right endpoint of my radius is sitting on the 1 minus y. The left endpoint is sitting on the 0. Okay, so now I'm ready to plug into my volume formula. Pi depth integral from lower bound to upper bound. Big radius squared. Now, this is what you're going to write on paper, but in your calculator, you're going to use what?
X.
X. So under Y2, I'm going to have that store my radius for the second example. The nice thing is that, once you have something in that form, you could just do second enter. So I could do that. Or you can scroll up to what you just entered in, and then just adjust the bounds and adjust the function that you're calling. Let's see if this will be able to convert to a decimal, sorry, a fraction. Again, we're leaving pi out of the calculator. So you can leave your answer as 1/3 pi or pi over 3 cubic units. Okay, any questions with part A? In part B, we have a different curve, but we're still rotating around the y-axis, so we know we have to, in a similar way, we have to rewrite our equation in the proper form. So try part B. I'll work on part B at the same time you do. Now, make sure that you're actually taking the time to solve for x. I see some students do this. Some students just swap the x and y. That's not the same thing. We're not creating an inverse function here. You got to actually algebraically move things around and actually solve for your x variable.
Is that rule true when we're like for like 7.1 when we're plugging it into the calculator?
What do you
When
mean?
we plug the function into the calculator and let's say we're doing right to left,
Mhm.
then would we can't just swap x and y, we actually have to solve it and then plug it in.
Right. Yeah. Solving the plug it in. Yeah. Now on the quiz, I'm going to draw all the graphs for you. So you're gonna have to. You're not gonna have to be able. You're not gonna have to worry about graphing a strange looking function. Yeah, I'll have all the diagrams already for you on the quiz. Now this is plus or minus square root, but we're only going to keep the positive square root because the negative square root will be in the second quadrant, and we only want the portion that shows up in the first quadrant.
Equation is above the other and solving integration faster.
And also finding intercepts, or if you want to find intersections. So my radius is right minus left. Right endpoint is sitting on the curve. Left endpoint is sitting at the 0. Our bound is from 0 to 4. As 4 is the vertex of my curve. Big radius, quantity squared. And now plug in. I'll have this one under y3, and I'll call this square root of 4 minus x. Don't forget about the pi, 8 pi cubic units. Okay, I like to focus on the right minus left because those are the ones that students have a bit more trouble with. So let's do a couple more. So on page 9, can we try part B for number 1 and 2? The key's on the next page, but let's see if we can set it up. Okay, page 9, let's just do 1B and 2B. If you do math 4, it'll get you that cube root. Doesn't convert to a fraction for me, so I just rounded it 3 decimal places and attached the pi at the end. Okay. Let's finish off with number 2, part B.
We have application problem.
It's just very straightforward. Find the volume of this, find the area of that.
Exam.
Yeah, on the AP exam, very straightforward. Yeah. Let me adjust the homework a little bit. So tonight's homework, we haven't done the washer method yet, so I'm gonna just move all this into tomorrow's homework. So if you guys can just do pages 9 and 10 for homework tonight. Sorry, which is that? Yeah, page 9 and 10. Yeah, we worked through a couple of problems from, these are all this method, so we can just focus on this method. So page 9 and 10, I'll send out a reminder tonight that your homework is just page 9 and 10. Take them for votes.
Mr. Yang, do you have a help section after school?
I'm gonna work with some individual students, but you can come in. Yeah.
Okay, so I just had some questions on the homework.
Okay.
I didn't really. I'm sure. High school, high school. Yeah, my God. Oh, thank you. Sorry. Oh, thank you, world.
We're doing like. I need a lot.
I'm 40. Okay. Great lights. Okay, so you got almost. Also got really tall. Is that working? Anybody? Never ordered so high. Well, really. Like that. Oh, I switched things up. Yeah, I knew it was gonna. It's good, but I just got. That's actually true. I don't know how much was this switch. No, oh, you. Funny thing is, there's no recovery from that one. I was just switching back and forth. You can see the guys first time switching the back and forth like. Oh, I guess the wrong one.
No, I was walking on the first page.
So we stopped, like, you're the 96 and then 95. Yeah.
Yeah.
You needed that, but you have the bus.
I'll take it.
You had like a low air. But, oh yeah, that's.
Not ideal.
Yeah. You know, look at. Not that anyone's now you're thinking.
I probably lost the points for forgetting to add for a minute on the end one out. So
Yeah, it sounds all right. You're actually. Nice. You're good at throwing
I
stuff.
don't even know what to do.
What'd you get? Huh? What'd you get?
I got nice.
If you get games, you don't talk about it.
Huh? We feel bad.
No,
We feel bad.
Yeah.
I did not make a 7. I already like good.
You can have like a bid.
Your beer fine, so.
It's like.
Now I just need to keep it up for real.
I'm feel from.
Dude, you gotta plan.
At least in 90s. Gotta get some fun. My kids in math races, like, you know, for this, you know how you're not supposed to do math races, just like, on the ground like this, they don't let them be paid. It's this. Actually, you know what I'm talking about, right? What do you do?
On the right.
Oh, what do I like, guys? Right now, I'm about like.
Have a great day, guys. See you tomorrow.
So, my maintenance, I'm doing about.
As you're about to get started, sorry, it gets finished.
Off of
Where
the.
everybody- She's like, don't talk to me that way. I'm literally dying. I was like, this is actually so funny. Yeah, I'm literally dying. I'm gonna go right now. This is an ambulance. Have a good day.
Bye, have a good day. Bye. Thank you. See you.
No, bro, that's so hilarious. And then we're like, okay, we're like, get out of there. And he's like, Mom, you didn't have to. I'm fine.
I sent you a text.
Yeah.
I just wanted to, I have to take my lit test fifth period, so would I just come in tomorrow morning and take it? Perfect. Thank you. What time are you gonna?
7:30.
Perfect. Thanks.
I was like yesterday.
Next Tuesday. Yeah. So we will cover content Monday through Wednesday, review Thursday, Friday, Monday, and quiz Tuesday. After that, we're gonna look at AP review, like AB content FRQ review. So after that, we'll still have a test and a quiz, but like AB FRQ content.
No, because I said this, oh wait, I'll be asking for because I'm not gonna go, but that's all I'm not gonna go. Like, I know. Really good time. Why don't you go? What? Why don't you go? Actually, okay.
I think my quiz during lunch, or should I take it? I think during lunch. Which was period? Fifth period.
Yes. What's that? Oh, this is key. I know it is right now.
Okay, all right.
So, nice. So maybe the three, but like I'm doing stuff. It just. I'm not there. So.
Okay, that's it.
Just wanted to ask. And I'm assuming that is it just like you did an exquisite class I still have something stuff. So I can do it right now, but I need some more period, I can come back or I have to get a period. I need some more, I can go into class.
Or I can give you one page now.
Oh,
Yeah, I can do that.
I do get.
What is yeah,
Lester?
up here.
Okay, and we go. Oh, wait, hold up.
No, Matthew.
Move down to one and you went behind. Even the slope in the west. You're going, I just want to win tonight. Well, lucky Rob, I don't know. It's actually so bad that like, oh no, like box. We're in the now, right? So, Brandon. have to put it in. Yeah, we're all in. Still the one.
I still like Lisa by.
No, we have a this for. You'd rather actually get out. That's all that's fine. Something. That's why I asked about my sister, right? Oh, yeah, it's only like acid. Like, it's like these friends, like. Like, I know.
I think this is.
Is there any like? Yo, no.
I understand like there's a football at like I understand you're not even supposed to be like on that.
You're right. That's the thing.
Yeah, no, I was only installing, yeah, I didn't install you, but.